Sessions. So we're going to go ahead and get started with Terry Fong. He's going to be helping us with Parallel Session 5, Astrophysics Enabled at the Moon Overview Talk, the Gateway Enabling Infrastructure for a New Era of Lunar Robotics. Thank you, sir.
Well, that's going to be the longest title I've ever heard associated with any talk that I've ever given, so I'll take that as a good sign. Good afternoon, everybody. I know people are still rolling in, coming back from lunch. Hopefully this will get you energized and thinking about this afternoon. This is meant to be an overview talk about the astrophysics session, but when I talked to several people about this particular talk, there seemed to be broader interest in hearing about some of my thoughts and things that I've observed associated with the future for lunar robotics. So this is a little bit broader than just astrophysics, although I hopefully will support some of the papers there. So this talk is entitled The Gateway Enabling Infrastructure for a New Era of Lunar Robotics, and I think this is really driven by the fact that in parallel to everything that's going on in the science world, there is the development, at least the planned development of Gateway. Whether you call it Gateway, the Deep Space Gateway, or the Lunar Orbiting Platform Dash Gateway, it's all the same thing. But the point is that I think it's a wonderful new potential piece of infrastructure for lunar exploration and lunar science. And so let's see if this clicker works. We'll get right into this. As you've heard and probably seen, NASA has spent a lot of time recently formulating the path forward for lunar exploration. On the human side, in human exploration, you probably heard from Ben Bussey yesterday, if you were here, of some of the things going on. And one big primary thing that is focusing a lot of attention right now is the development of Gateway, starting with the creation of the first element, the power and propulsion element, ready for launch around 2022, leading to the establishment of the initial operating condition of Gateway in lunar orbit in 2024. Dates all subject to change. But the point here is that this is something that is a brand new capability, a brand new piece of infrastructure in lunar orbit, something we've never had before. And I want to spend the next 15 minutes giving you some thoughts about how we can make use of that for lunar robotics. So the Gateway, if you haven't spent any time looking at that, really is a notional thing at this point. This is the sort of NASA referenced notional picture about the Gateway, the fact that it'd be an orbiting spacecraft visited by Orion. And that's an interesting point there, that the overall design is that we would have a station, this Gateway, that's only intermittently crewed. The idea that you would have astronauts there perhaps only 4 or 5 or 6 weeks out of the year, and the rest of the time it would be basically an uncrewed station in lunar orbit. And what that means is that you have to think of it very differently than space station. It is not someplace where there will always be astronauts doing experimentation or other work inside an IVA space, but rather it's a spacecraft that we should take advantage of for doing a lot of different things. Gateway will initially be built up by a number of different elements. The first, as I mentioned, is the power and propulsion element. That's designed to provide initial capability, providing power to the Gateway, attitude control, orbit maintenance, all those good things for basically keeping the spacecraft functional in orbit. Then you add to that a habitation module, which of course is required if you're looking for crew being part of that, and a logistics module to allow you to deliver cargo and supplies to enable extended crew missions. These are the basic building blocks that go into creating the initial orbiting platform near the moon. Now, the development here is laid out over the period of the mid-2020s, starting off, as I said, with initial power and propulsion element in the year 2022 approximately. And then this builds up to creating a platform where you could have 4 astronauts living perhaps for 4 weeks or so 30-day type crew missions. And then, as I said, the really interesting part, at least from my perspective, is what do you do with this platform even when crew isn't present? Something that we've never really contemplated for a space station. The idea that we have this very large piece of infrastructure sitting near the moon and being something that we can take advantage of for lunar exploration, in particular lunar robotics. So one of the things that's been going on across the world, it's not limited just to NASA, I mean certainly there's a lot of activity in Europe and ESA, is trying to plan for how Gateway will be utilized. There have been a number of different things in terms of workshops and calls, requests for information over the past several months. I'm sure that a number of you out there probably attended the science workshop that took place in Denver in February. And all of these are really efforts to try to come up with driving requirements that goes into the design and development for Gateway in terms of how Gateway could be used by the commercial sector, how it could be used internationally, how it can be used for science and research, which is, I think, our primary interest here, but also how it can be used as a technology piece, both for demonstrations as well as basic capability. All of these things are things that I would encourage you all very strongly to get involved with right now, because we're at the basic definition phase for Gateway. It's our opportunity right now to influence what Gateway is capable of and therefore how we can make use of this going forward. One of the things that I think is really important to think about is how it can be used to support lunar robotics. You know, Gateway is something that can provide a unique piece of infrastructure that I think, frankly, has been missing for a very long time if we're thinking about lunar exploration. You know, you look at the Mars community, and I know there are Mars community people out here. You know, Mars has really been enabled by the fact that we have extensive infrastructure. We have communications that have been there in orbit over a long period of time, and those orbiters provide additional remote sensing information, especially high-resolution imaging that gives us digital elevation maps and positioning of our surface missions. Well, we look at the moon today, and we have LRO, of course, but LRO is not going to be there forever. LRO is not designed to be a comm relay. It's really designed for imaging and mapping as well as carrying a couple other instruments. But the point here is that we have an opportunity to really outfit Gateway in a way that can serve those functions and more. I mean, Gateway can provide infrastructure if we push at this moment in time to do things like comm relay. So we can provide or increase the link availability to places on the surface or in orbit about the moon. It could also be used as the way I think of it is as an orbital computing platform. You know, the fact is that none of our surface missions to date, whether we're talking about the moon, Mars, or any place else, has, you know, the computing capability that we'd really like to have. No rovers, even, for example, the Resource Prospector rover that was under design up until recently, had as much computing as we would like. But think of the idea of having an orbital platform in the Gateway where we can tap into its onboard computing and its data storage and its communication networks. A wonderful opportunity for new infrastructure. In addition, you know, the Gateway can carry additional imagers or instruments, so we can do mapping from orbit. It could be a source of positioning and timing information. It could possibly be used to provide power through power beaming, whole variety of other things. The point here is to think of Gateway not as something that competes with science and robotics, but really as an enabling piece of infrastructure. I think that's a really exciting thing. And if you look forward to some of the ways that people are thinking about this, the Human Exploration and Operations Mission Directorate recently had a request for information asking for ideas for technology utilization. And one area they called out was this area of cloud computing. The idea that the Gateway could provide these on-demand services, especially to missions on the surface or missions that are in lunar orbit. Another area was this idea of providing on-demand orbital infrastructure. So the idea that you might deploy from Gateway short-duration orbital services. So for example, a set of CubeSats that could provide during a particular mission, let's say that you had a short-duration surface mission, be it a lander mission or a rover, the idea that you could have small sats providing comm relay or real-time imaging from orbit is a very interesting idea. It's something we've never tried before. So I do, want to encourage you all, when you have the opportunity to provide input and you have the opportunity to talk to people, especially within NASA that are starting to work on the design and development of the Gateway, to take advantage of that because there's a real opportunity for us. I think the other thing that I've heard a lot of interest in is how the Gateway can support lunar robotics operations. There have been a lot of discussion, a lot of research projects actually over the past decade in how you could have astronauts, so crew in orbit, working with robots on the surface. The whole idea of sort of making Avatar become real life. But I want to point out that's only one concept of operations. The fact that, yes, you could have astronauts performing real-time manual control from a spacecraft is only one of many different ways to construct a robotic mission. In fact, you could look at combinations of crew in orbit and mission control here on Earth working together to carry out these functions. But if you're going to do that, you should also consider the fact that there are many, many other variables associated with that in terms of the communication availability, the mission requirements, the orbit of Gateway, system capabilities, lots of different factors. The point here is that it's a wealth of opportunity here for thinking about different ways of running robotic missions. They're not just, so to speak, your grandfather's robotic missions. The fact is we have opportunity to look at having crew involved from Gateway, having Gateway provide a relay service, having people in mission control operate in a more interactive manner than any sort of robotic mission we've had to date. And that takes me to the last bit of this quick overview here, which talks about the state of the art in space telerobotics. NASA for the past decade has been doing a lot of research and development, trying to look at different ways of controlling these robots, whether this is from orbit or from the ground in a more interactive fashion. Basically trying to create robotic systems that are far different than the way we've been operating robots on Mars for the past decade. Some of the work was driven by prior concepts. So some of the people out here, especially from my friend Jack Burns and those from Lockheed probably recognize this slide. Back in 2011 or so, maybe even earlier than that, there was a concept of how you could have Orion at EML2, where astronauts on board Orion would be working with the rover in real life. That led into a project within NASA called the Surface Telerobotics Project that simulated this, making use of the space station back in 2013 with 3 different crew carrying out a simulated lunar mission. So we had astronauts on the ISS working with one of the rovers here at Ames to carry out a simulated mission of basically surveying, deploying a radio telescope, and then inspecting that. Just to give you an idea of what this looks like, this is Luca Parmitano. This was almost 5 years ago. He's working with a graphical user interface on a standard ISS laptop, and he's working with this, which is the K-10 rover, operating actually just like a half mile from here, outdoors at NASA Ames. The interesting thing about this here is that you had a single crew member working with this robot using a highly interactive real-time display where you have 3D rendering of the environment. You can see the obstacles, live telemetry from the data from the robot, streamed images from its cameras, a highly interactive system of the kind that we've never seen before for planetary exploration. And the fact is here that I think the testing that we did showed that it is entirely feasible for astronauts to remotely operate a planetary robot from orbit. I think in the following session in astrophysics, you'll hear about some of the concepts of what you could do with such a system in terms of laying out future instruments for making astrophysics observations. In any case, I'll just wrap up here and remind you all that the Gateway is something that NASA is spending a lot of time and effort at this moment in time designing, developing. We anticipated being up in lunar orbit within the next decade or so. And it is truly an interesting time for us as we're thinking about the design and the requirements that drive the development of the Gateway. And so as you go forth from here, as you talk to people, give it some thought about how can the Gateway most benefit lunar robotic missions. Don't be satisfied with the way that we've thought about design of missions for Mars, but rather think about how we could use this new wonderful piece of infrastructure to enable more science and exploration missions, perhaps involving astronauts, but really then focused on what sort of additional studies and development testing should we be doing at this moment in time to make sure the Gateway is something that will be really productive for all of us. And with that, I think I have maybe like 2 or 3 minutes for questions if there are any.
Yeah, I'm interested in hearing more about the infrastructure, and in particular the first phase of the Gateway, which presumably will be the first asset that we'd all have access to. We're all familiar with our missions where we have to go through the DSN and we have to schedule time, we have to buy it, we have to go in the budget. What's it going to cost? Are we going to have problems scheduling? How's it going to work so that it's advantageous to us as we plan missions?
I think you touch on a couple of really good points there. One is that in terms of communications, the Gateway by itself obviously is not isolated. I mean, it does exist in the rest of the infrastructure, so to speak.
There's none right now.
Well, there's none right now. But DSN, for example, we know that DSN is quote unquote optimized for deeper space. It's not really particularly optimized for cislunar space. And we know this just in terms of like recent work on RP, in terms of what is the bandwidth and availability you could have for a surface mission. Well, clearly those same sort of constraints come into play when you look at the Gateway. In fact, part of the concern I think for developing the Gateway is when crew aren't on board, how much availability will we have to talk to and from it? So clearly, I think that the engineering of the gateway is going to have to take into consideration some of those other constraints. But I would say that if, as a science community, we feel that it's extremely important that we have more availability, for example, for communication to and from the surface relayed by gateway, that we push right now to make that a priority. Because if we don't push right now, it won't be available.
Well, that's why I'm asking right now, is because we need infrastructure in order to access the far side of the moon.
Yep.
Absolutely essential. We need it for a network science, absolutely essential. In order to proceed on those really high priority science objectives that are the highest in the decadal reports, we need to have capabilities like this. And it's nice that the gateway says, okay, we're going to start doing that. So I want to translate that back to our planning. Is it going to be an order of magnitude cheaper than using the traditional with taking our own relay? How does it translate reality in terms of us planning now?
Yeah, unfortunately, I wish I had the answers to your questions, because I think they're exactly the right ones to be asking. That if we believe that Gateway is going to serve a useful purpose, whether it's providing services to a mission or just the overall cost that it's going to consume in terms of dollars from other things that NASA might want to do, where do we end up on that? And I think that I know in terms of like gateway engineering, which is really just started right now, those are some of the key questions that people are trying to answer. But I would contend, I would certainly urge all of you that if you believe those things are critically important, you say, hey, look, I've got a mission, but my mission that I'm trying to push forward will only be successful if COM only costs so much. And if Gateway makes it impossible to accomplish that, then my mission won't succeed. Those are the kind of things that people who are starting to work on this at headquarters and beyond certainly need to hear. So I don't know if Ben is still here, and there he is right there. I mean, he's probably going to run away since I've pointed him out now. But I think these are the kind of information that Ben had started collecting at the science workshop in February, and I know is being taken a look at by HEO. And I would urge all of you to continue pushing up, whether this is up through SMD or through HEO, the fact that Gateway, if it's going to be there, should be a useful asset for the science community.
Yeah, I just had a thought. Would this be available to foreign partners? It might be a way to share the cost.
Yeah, so I think that one of the things that to me is a very hopeful sign is that there is a tremendous amount of international interest, especially in Europe. Just this past week, there was a meeting of the ESA ministers, and they collectively decided that yes, the Gateway was a very high priority for Europe, and that there was I believe, a set of recommendations that would be pushed forward to the next ESA Council meeting, which I guess is not going to be until December, or maybe it's early next year. But the point is that Europe has said that they want to play a very major role in Gateway, which I take as a good sign of there being a lot of international interest of being involved with Gateway.
Yeah, I just want to come back to Carly's comment. Carly, I will reach out and double check, but historically, if you're running a science mission, you don't pay for that downlink. You don't pay scan for DSN time, etc. So I can't imagine. I would be surprised if this is any different. I've already written an email seeking clarity, but I would think you could just assume that it is an asset that is there for you to use. How you handle prioritization, well, that will be a good problem to have when we've got so many things wanting to use it.
Yeah.
Excellent. Thank you.
Okay.
My name is Nori Mitsuba. I come from JAXA, the human space fighter. So now, JAXA, our directorate studied the demonstration of robotics using ISS conventional instructions. Yeah, because we have to saving the operational cost by using robotics. So I think maybe it's. ISS is a very good infrastructure to demonstrate to human, robotics, to saving cost. We like to communicate.
Okay, great. Yeah, I mean, I think ISS has been a very good orbiting laboratory. I certainly hope that Gateway becomes one as well. Obviously, I think Gateway is going to be quite a bit different, though, than ISS, but hopefully that's a good thing. I think the fact that ISS is in Earth orbit, is both good and bad. It's good because it's easy to get communications and we can get to and from it, but it's not really an ideal location if we want to use it for other things other than maybe Earth observation. Which is not to say that Earth observation is bad. It's just, I know I'm among a lunar science